And what we're doing tonight is, first of all, the second half of word translations, then also the essays after that. Then I'll be handing it over to Emily to do modifiers, and finally a mid-course review at the end. That's not going to be a full review, but we'll touch on some problems you've seen before and also some new problems. So let's dive right on in. This second part of word translations deals with overlapping sets, combinatorics, and probability. Three areas that are considered pretty tough by students and are pretty tough on the GMAT. So let's go right into a problem. I'm going to give you 2 minutes. Go ahead and get started. I'll time it on my stopwatch. Go. Okay, that's 2 minutes. Go ahead and give me an answer or put in a guess. Okay, I'm only getting guesses from a few people. I'll admit, when I first saw this problem, I got it wrong. So go ahead, take a shot. It looks like we're getting in guesses all over the map, answers all over the map. That's fine. What I'd like you to do now is to type into the chat window what type of problem you think this is. Go ahead and type it in. It's going to be private chat to me and Emily. Yep, you probably got a hint from the previous slide, and you won't quite get that hint on the GMAT. But I'm seeing some answers here. Overlapping sets. Now, I also see some other ideas here of probability. And probability and overlapping sets can be related, but it's not actually asking us for a chance of picking a particular type of test taker. It's just asking for the percentage. So how can we tell, let me go ahead and put it back on, how can we tell that this is an overlapping sets problem? I'm going to put it back on public chat. Go ahead, type in, how can we tell if this is an overlapping sets problem? No thoughts on this one. Let's see. How can we tell that we have overlapping sets? Anyone who went ahead and typed that in? Brooks, jump on the mic and let us know what you think. I didn't pick up your audio there. Give it a try again.
Can you hear me now? Okay. The first division that I saw was that it would be either above 650 or below 650. And then the other group that I saw, or the division, I guess, the way to divide up the group would be between those that were, who took it once or those who took it more than once. So I could make columns and rows based on the once and the more than once, and then above or below 650. And the percentages they gave kind of, when I sketched it out, fit into those categories and added up.
That's exactly right. The way I recognize this is if I have an overall group and then I'm splitting it into subgroups, and maybe I'm doing those subgroups a couple of different ways. One is by score, so I've got a lower score and a higher score, and then by number of exams. If I've got these two different ways of splitting up the universe into subgroups, then I've got this overlapping set thing. Now, I want to give you an analogy. You might think of a pizza here. And one way to split up a pizza is to decide, say, do you like mushrooms? And if you like mushrooms, but your friends who you're sharing the pizza with don't, then what you might do is put mushrooms on some part and no mushrooms on the other part. It doesn't have to be half and half, but you might set up your pizza this way. Then what if there's another division in the group of you and your friends about what you feel about pepperoni? So some of you like pepperoni and some of you don't. In that case, you might put pepperoni on some of the pizza and not put pepperoni on another part of it. Now, again, I don't mean to imply that it's half pepperoni and half not. You might do that, but you might not. However, notice what this does is it splits up the pizza, the universe of the pizza, into 4 quadrants. We got mushroom and pepperoni. We've got just pepperoni and no mushroom. We've got just mushroom and no pepperoni. And then we have nothing at all, or just cheese, say, which we assume might be on everything. This is how I really think of the double set matrix. When you set up a double set matrix, what you're doing is creating a pizza. And the way the pizza looks, I'm going to outline it in red here. And all we have to do is make sure that we name these columns akin to mushroom and no mushroom, and that we name the rows also akin to pepperoni and no pepperoni. And Brooks gave us a good breakdown. Say the mushroom would be the score and the number of exams would be the pepperoni or not. And the big thing that you have to do is make sure that you put opposites next to each other. So if we put score along the top, then what we have to do is make sure that we put less than 650 on one side, 650 or greater on the other. It doesn't matter whether we put the lower score on the left or on the right, but we have to make sure that we don't mix this up with the number of times that you take it. For instance, with the, clicked that wrong. You wouldn't put mushroom here and pepperoni here. You want to make sure that when you choose this category, the category to its right will be the not category, the no mushroom. So, if we've got less than 650 or 650 or greater here, then that's just akin to our mushroom and no mushroom. And likewise, we put the number of times down the left-hand column here to indicate rows, once only and more than once. Now the real key, the real advantage to this over the Venn diagram, which you should have read about in the book, is that it allows you to take subtotals in all kinds of different ways. This last column and this last row are really important. They represent the totals, the subtotals. So what I'd like you to do is to take your laser pointer, and remember the laser pointer looks like a sort of exploding firecracker. It's red, sort of a red exploding stick. Go ahead and put your laser pointer on the box that will contain people who scored less than 650 only once. Go ahead and put your laser pointer on that. Good, I want to see some fireflies dancing around, exactly. Now put your laser pointer on people who scored a 650 or greater, but took the exam more than once. Go ahead and move your laser pointer. 650 or greater more than once. Cool. Now I want you to put your laser pointer on the people who took the exam only once. I don't care about the score. The people who took the exam only once. Good, I'm going to be the hand or the smiley face. The subtotal, people who took the exam only once, goes over here. How about the people who scored less than 650? I don't care about the number of times they took it, less than 650. Yep, you know how to use this. Over here, that's right. And finally, where would I put the total, as I put it? The total, exactly right, goes down here. Very good. So, let's take our fireflies, our little laser pointers, off. And as we look at the problem as a whole, let me switch back to the pointer here. As we look at the problem as a whole, we see that there are no actual numbers of people. The number of GMAT test takers last year was, or the number of GMATs that were taken was pretty close to 250,000. By the way, these stats are not real. We just made them up convenient for this problem. About 250,000 tests were taken last year, or close to it, but that number, no real numbers of GMAT test takers are listed in here. So type into the direct message window what should be our total. What would be a really convenient total? Go ahead and type in a number of people. Should we take 250,000 people? Awesome. I'm seeing hundreds all over the map. That's exactly what we should take. When we have a problem that just gives us percentages and we only care about percentages, pick 100 for the total. Now, what I'd like to do is kick it to, say, Andrew. How can we process this first piece of information that I'm highlighting in yellow? Where should I put that on the board and why? Jump on the mic.
He says, I guess I key in on more than once. So that's what I have as opposed to only once. So that was sort of one discrepancy. And also higher a score higher than 650. And so therefore I put that in your box. I have that on, I guess, the lower right hand corner.
What does everyone think? Give smiley faces or thumbs down if you agree with Andrew or you don't. Should we put in 10 in the lower right hand corner of the red box? Seems like you got a lot of love there. So we should put 10 there. Notice it says 10% of GMAT test takers. Which GMAT test takers? All GMAT test takers. In our universe, that's 100 people. And so that's 10% of 100, or 10 people. And what do? They do two things. They take the exam more than once, and they have a high score of 650 or greater. Now, if you set up your chart with these reversed, or with, say, the number of times up top and the scores down the left, that's fine. You just got to make sure you follow whatever scheme you set up. Okay, so let's look at the next one. What should we do? Go ahead, type into the direct message window. What should we do with the part I'm highlighting in blue? 20% of GMAT test takers who take the test only once have a score of 650 or greater. What should I type where with that? Go ahead, type in. Yep, so it looks like we're talking about this box here, and I should put a 20 in there. And you know what? If you did that, you would have fallen into the same trap I did, and you would have gotten this one wrong. Sorry. What's different about this one? And not just the fact that it's talking about a different box. How is this one phrased differently? Just think about that for a minute. How is this one phrased differently? I'm going ahead and telling you, putting 20 right where I've got my finger is wrong. Oh, Danielle, jump on the mic.
It's 20% of a subset. It's 20% of those test takers who take it only once.
You nailed it. That's exactly right. Notice the key word here. I'm going to highlight it. Who. This is not 20% of all GMAT test takers. There's no who in that first yellow highlighted part. It just says 10% of GMAT test takers. And that you can assume is all GMAT test takers. There's no subgroup that we're taking the 10% of, whereas we're taking 20% of a subgroup. So show me, how should I deal with this then, Danielle? Let me kick it back to you. So how can I represent this?
Let's see. So of the ones who took it, what I think you would assign X to maybe the total of once only, and then 100 minus X to the box right below X. And in any case, for the 650 or greater and once only box, you would do 0.2 times X, I believe.
Okay, thumbs up, or I'm sorry, smiley faces or thumbs down. What do you all think? I agree. Applause. That's strong. Exactly right. You don't know what that subtotal is of people who took it only once, so you got to assign a variable to it. And therefore, this is 20% of that. Nicely done. Nicely done. Now, it's possible that you read that blue part and you're not sure what to do with it. So you might skip it and come back later and try to process some of the rest of this. So let's go on from there. Razi, what can you do next? Go ahead, jump on the mic.
The next line, which is 40% of GMAT test takers take the exam more than once, we know that 100 minus X equals 40, which means the number of people that took the test once only is 60, and then we automatically get the top right box, which is 20% of 60, which is 12.
Awesome. Finish it out for us.
So the number of people that got less than 650 and only once would equal and took the test only once would be 48, and then the number of people that took it more than once and got less than 650 would be 30. So the answer would be what percent of GMAT test takers have a high score of less than 650. I'm sorry, wait a minute. I will be 30 plus 48, which is 78.
Awesome. I totally agree with that. So once you have that insight that this is not 20 that goes here, notice you could have gone to the 40% of all GMAT test takers, put this 40 in here, and you wouldn't necessarily have to have introduced the variable X. And then the rest of it is just making sure every column and every row adds up. I usually finish the whole thing out, and when I'm setting these up, I often circle the box I'm looking for. It might be a ratio of boxes. It might not actually be a single box, but I circle those boxes I'm looking for. So what are we left with here? Some key points. One, how to recognize that we've got an overlapping sets problem. You want to think about the big group split up into subgroups, and you typically have two dimensions here. In real life, we had score and we had number of exams, but you could think of it as mushroom and no mushroom, pepperoni and no pepperoni. And if you can map your problem onto the pizza, then you're all good. Notice we who wrote this problem anticipated that you might put 20 here, in which case you'd get 70 for this answer. And Emily's making a great point in the chat window. Often what we'll do, or I should say the GMAT will do, is put in a wrong answer that's somewhere on the right chart. We saw that last week with rate, time, and work, or distance, where you could solve this whole thing out correctly. And notice 22% is here as a wrong answer. And so if you misread this thing and went for the high scores, then you put down 22%, and that would be such a shame to get the thing right, in a sense, but answer the wrong question. So, any questions?
Yeah, I think we have lost him temporarily. I don't know if you guys have noticed, he's joining us from a different location this week, so he might have some connection issues. I think he was about to ask you guys if you had any questions on this one. If so, I'll field them. If you're good to go on this one, go ahead and give us a smile.
Sorry about that. I'm dialing in from far away, and the connection here, even though I'm wired, is a little bit it's not as good as was advertised. So if I get booted, Emily will jump right in. Okay, so let's move on to the next problem here, and I'll give you 2 minutes, and I'm going to cover up some stuff I just put down there. Go ahead, you've got 2 minutes. Go. Okay, that's 2 minutes. Put in your answers, please. Now I'm seeing a mix of C's and D's, and some A's. All right, let's give this one a try. And what I'd like to ask you all is how good you feel about what I'm going to call the Chili's principle. And the Chili's principle is the restaurant Chili's. Let's imagine that you have a choice of an appetizer out of 4 different appetizers, A, B, C, or D. And you could choose one of 5 different entrees, numbered 1, 2, 3, 4, 5. Go ahead, type into the direct message window, how many different meals could you have consisting of 1 appetizer and 1 entree? Go ahead, type it in. All right, what do the rest of you think? Smiley faces or thumbs down? Everybody weigh in. If only we could just do this during the exam, I know. We could just like say, hey, you know what, I want to ask my class, what do they think about this problem? Very good. It is a multiplication, and you can look at it when you have just two sequential choices as a little table. You're choosing your appetizer across the top, you're choosing your entree along the side, and you're just picking a box. How many boxes are there? 4 times 5. So this Chili's principle, which we call in the book not Chili's, but the fundamental counting principle, is essentially multiplication. And notice what's going on here is that you can't retrace any point. That is, the mouse can't. So the mouse has 1, 2 choices at this first juncture, 2 choices at the second juncture, and finally, and notice that you don't have any choice to go backwards at these places where it comes back together. And then 3 choices here. So what we want to do is list out how many choices we have, and then finally multiply them up. This is a very GMAT-like problem. 12 total paths. Notice this is a relatively high-numbered problem as well, number 135, and yet you look at this and you say, man, why is that? That's because many people do not learn combinatorics even at this level of the fundamental counting principle. And notice they put in some good trap answers, like the sum here of 2 and 2 and 3. This fundamental counting principle underlies all of combinatorics, and sometimes it's literally just counting the number of choices you have at each juncture and then multiplying those up. So, with that, I want to go to another problem. Any questions on this one before we move on? I know I'm going through this one relatively quickly. Okay. So, now imagine that you have 5 different objects. This is the problem that we've written. A, B, C, D, and E. My question to you, and I want you to type it into the direct message window, how many different ways can you put those 5 objects in a row? Go ahead and type it in. It'll be private to us. Fantastic. I'm seeing a lot of right answers here. One way to derive this is to imagine that you have those 5 objects in a pool, and then you have 5 places you're going to put them in. And here on the left, go ahead, type into everyone. How many choices do we have for the object that goes in the first position? Type it into all. Yep, we've got 5. Separately, how many choices do we have after we've placed that first one? How many choices do we have for the next? You're already there. 4, exactly. And then 3, and then 2. And finally, we don't have a choice for the last one. You can discover this principle by simply trying to write what's called an anagram, or a rearrangement of the letters yourself. You might start with B, and then say, okay, I've placed B. How many choices do I have for the next one? I'll place A. Okay, I can only pick from the remaining 3 now. C. Now I will do E, and then finally I have to put the D down. So I now, by the Chili's principle, have to multiply all those together, and I get 120. Remember, I don't sum these, I multiply them. So the key thing here is that this idea of you losing one choice every time you place one of the objects, and then multiplying all the way down through to 1, is so important that it's given a name. As many of you typed in, it's called 5 factorial, or written 5 with an exclamation point after it. So it's interesting. 5 factorial is 120. Anyone have an idea of how big 10 factorial is? Is it twice as big? Is it 4 times as big? Go ahead, type it in to everyone. How big do you think 10 factorial is, roughly? Give me an estimate. Don't actually do it, just estimate. Yeah, that's actually pretty good, Andrew. It's 3 million, roughly. So, yeah, exactly. It's 5 factorial times 6, 7, 8, 9, and then 10. So it's a lot bigger. This is known as the combinatorial explosion. You only have 120 ways to put 5 objects that are distinct in a row, but if you have 10 objects, just twice as many objects, suddenly you have way more ways to rearrange them. We could think of that 120 as actually literally listing out 120 different anagrams of the letters A, B, C, D, and E. So I've only listed a few here. Now, let me ask you another question. You have 5 objects, but now 3 of them are identical. I've named them A, and then kept the D and E. How many different ways can you put these together? Go ahead, type into the direct message window. It's private to us. If you're not sure how to count it, let us know whether you think the number is bigger than 120 or less than 120. Okay, good. Now, one way to think of it is we are going to have fewer than 120. Everyone who typed in said it's going to be less than 120. And that's because some of these ways, some of these separate ways here, are now all counted as a single way of arranging these. So, put your laser pointer, go ahead, pick up your laser pointer and point to any of these ways that, if you change the B and the C into A's, would be equivalent to this. In other words, if you changed B's and C's into A's, which ones, 1 or 1s, would be equivalent to A, D, E? Yep, that's great. I'm seeing fireflies swarm all over these first several, and that's exactly right. How many turn into AAADE? There are 6, because those first 3 letters could have been rearranged just on their own in 3 factorial or 6 different ways. If you just have A, B, C, you can rearrange them in 6 different ways, which is 3 factorial. So notice what we've done is taken those 6 ways and collapsed them into a single way. And it would be a separate thing to have A, B, D, which would be starting here and going down. So for every 6 of these, you're only going to have 1 of these. And so the principle becomes this. Oops. The principle becomes It's the pool, which was originally 5 objects, divided by the number of repeats, which in this case is 3 repeated objects. So what we have is 5 factorial. Oops, I took that in as the percentage sign. 5 factorial divided by 3 factorial. So the correct answer here is 20. We do not subtract off 3 factorial, as some of you wrote. We divide by it, because what we're doing is we're taking the 120 different ways here and grouping them into groups of 6, and then collapsing those groups of 6 into just one separate way. So we'll only have 20 different words in this list. So 20 is the correct answer. Last one of our little problems here is this one. 5 objects, 3 are A's, 2 are B's. How many different ways can you put them in a row? Go ahead, give that a try. Very good. You've been thinking this one out. So you can think of it as even going further than this one. If we collapsed the D and the E into each other and we said they're both B's, then we're going to have only one list down here, one item on the list, I should say, for every 2 items up here. So what I have to do is divide even further. And the basic general rule is, again, dividing by repeats, but you do it separately. So it becomes 5 factorial divided by 3 factorial and 2 factorial, which when you do that math out, becomes 10. By the way, fast way to do this math is write that as 5 times 4. I'll use the asterisk for the times so we don't mix it up with an X. And notice I've dropped off the times 3 times 2 times 1 already. And then just divide that by 2. So avoid writing out everything of every factorial, multiplying it up, and then dividing. You want to cancel factors whenever you're doing these problems. Okay, good. So now that takes us to the next problem. Go ahead and give this one a try. Pull in your answer when you're ready. Go. Okay, that's 2 minutes. Pull in your answer. Got them from those folks? Okay, so this takes us to one of our most powerful little tools for combinatorics, which is known as the anagram grid. And the anagram grid gives us an easy way of dealing with straightforward combinatorics problems, ones that don't involve weird constraints. So the way to use this grid is to imagine that you have your pool of people. In this case, that pool is 9. And we put that on top of a grid. And the reason we're going to do that is that we're going to now assign labels to these 9 people. And the way we assign labels will depend on the way the problem's written. But if you're choosing a team or a subgroup out of a group, and you don't care what order you pick that team in, then the labels that you're assigning are simply Heidi Klum's labels, Project Runway. What are her labels? Go ahead, type it in. What are Heidi Klum's labels on Project Runway? What does she tell people? Anyone watch that show? Oh man, I'm so dating myself. What she says is that you're in or you're out. Yes or no? Are you on the team? So, the labels you're going to assign, sorry if that was a little weird of an analogy, but the labels that you're assigning when you're picking a team and you don't care what order you pick the team in, you're not assigning them to particular positions on the team, you just want to know, are they in or are they out? Yes or no? You're just going to assign Y's and N's. That's it. And now, what you're going to count is how many different ways can you rearrange those labels, the Y's and the N's, which is equivalent to the problem we were just doing. If you've got 3 A's and 2 B's and you want to rearrange them, then you take the pool and you divide by one repeat and you divide by the other repeat. So what that means here is that we're going to just say, okay, how many ways can we shuffle those letters? Simply take the pool and divide by the repeats. And those repeats are the ins, who's on the team, and the outs, who's not on the team. So you take 9 factorial and divide it by the 5 factorial and the 4 factorial. If you wrote the whole thing out, which again I don't recommend you do, you'd get this. And now you should just slash and burn. Cancel out things, hopefully even before you've written them. Don't even bother writing the ones, because they're never going to matter. And then continue to cancel factors. Say the 4 and the 2 cancel with the 8. The 3 cancels out part of the 9 and leaves you with 3. And then when you multiply up what's left, you get 126, which is D. So, some people want to remember, okay, when does order matter and when doesn't it? Basically, if you're picking a team, order does not matter. And then what you're doing is you're always going to divide by the ins and the outs. In fact, you always divide by the outs no matter what, but the question is whether or not you care about differences between the ends. And Emily's put this a great way. Do I care about any differences among the people who are in? And if I don't, then I'm dividing by a factorial of those two. However, if I care about the order I'm picking them in, if I care about the differences in the labels there, then I wind up not dividing by the in factorial. I wind up giving them different labels here, like say point guard, shooting guard, center, whatever the other positions are. So that's the nice thing about the anagram grid is it handles both permutations and combinations, for those of you who know those terms, which are cases when order doesn't matter and cases when order matters. All you have to do is make sure that you are assigning labels, and that you are assigning labels identically if you don't care about differences among those subgroups. For instance, I don't care about the differences among the subgroups of losers who don't get on the team, and I don't actually, in this case, care about differences among the winners either. So I divide by both the ins and the outs. So, before we go on, There's a great question. Could we just use the slot method on this? And the answer is you can use the slot method. You could say, okay, I've got a pool of 9 people, and I'm picking 1, 2, 3, 4, 5 positions, and I have 9 choices for the first, 8 for the second, 7 choices for the third, 6 choices for the 4th position, and 5 choices for the 5th position. However, if I multiply all those up, I'm overcounting because the slot method inherently cares about order. So I can do this as long as I make sure I divide by all the different ways I can rearrange these 5 people. So I can write 9 times 8 times 7 times 6 times 5, but then divide by 5 times 4 times 3 times 2 times 1. So it's a fantastic question. You just have to make sure that if you use the slot method, you know that you're saying order matters because you've put these slots in an order. And so if you want to use the slot method and then somehow take out the fact that order matters, then just divide by the factorial of the slots, and you'll get to the right answer. So notice here, you do want to make sure you do divide by that, that you get a smaller number. Because if you just multiply together 9 times 8 times 7 times 6 times 5, you get way too big an answer. So, any other questions on this? The 4 factorial in this case winds up being canceled out in the 9 factorial. So, if we go back to this guy here, we wrote it in such a way that I canceled 5 factorial on top and bottom first, but you could have canceled 4 factorial and only canceled 4 factorial on the top. Yep, that's exactly right. So, thanks, Emily. If we took the non-box stuff, then that would be what we have on the next page. The anagram method doesn't work very well for weird constraints, or you need to use it sequentially. For instance, there are some problems in the OG that involve committees made up of a couple of different types of people. And we go over those in our book. The key thing to remember with constraints is that you can almost always use this simple method to solve at least part of the problem, and then work your way through the rest of it, either subtracting off ones that don't fit the constraint, or even applying the fundamental counting principle to multiply together subcommittees. So let me make sure, I think I'm just glancing here. This is an area that raises a lot of stress among people, and I wanted to close combinatorics. We're going to hit one more before we're through. A pretty tough problem, but one more combinatorics problem. But I just want to make the point, don't over-stress about combinatorics. If you learn the anagram grid and you learn the fundamental counting principle, you'll be able to handle most of what they throw at you, if not really everything. Don't go crazy on this looking for problems either in our curriculum or way outside of it that are sometimes even too tough for the GMAT. It's easy for this area to seem tougher than it really is, and it's not taught to, I can speak from experience, it's not taught to American kids that well. So a lot of us never really learned this in the first place, so it becomes a source of stress. Let's do another couple of problems. I do want to hit that weird combinatorics problem before we go out. You have 2 minutes. Go to it. Okay, that's about 2 minutes. If you have not answered, or even if you have, I'd like you to type in privately, do you think that the answer is greater than 50% or less than 50%? Reread the problem and think about it. Greater or less than 50%? Ryan, if you don't mind my calling you, why did you say greater?
I said greater because the chance that it landed on heads every time would be an 8. So if you take the inverse of that, then that's greater than 50%.
Got it, got it. We'll come back to that particular way of doing it, but is there a way that you could intuit that it's greater than 50%? If you were stuck guessing, did you think of it that way, Ryan, at all?
Yeah, I mean, just if you look at the first toss, when you do the first toss, your chance is 50%. So if you're doing it again, then that just increases your chance.
Yeah, exactly. So, you only need one of the tosses to turn up tails. Imagine doing 10 tosses in a row, and you only need one tail to win. That's going to be a pretty high probability, pretty close to 100% of the time. You're going to get a tail somewhere in there. Now, one of the things that's cool about probability, which this problem is, obviously, because it uses that word, you might also see words like chance. One of the cool things about probability is that you'll see it again in business school. You'll see it in your stats class, in the first week of stats class, as I remember. And you're going to have to deal with this. So this is one of those few topics that actually comes back and is used not only in the first week of your stats class, but comes up in finance, comes up in decision theory, all kinds of places. And a technique that you'll learn about is decision trees, where you'll imagine that you are taking a path in the woods, and you're like Robert Frost, do you take the road less traveled by, or do you take this road? And you can just label them, say, for that first toss, heads and tails. And then you keep going from there. The second toss splits further. And then you finally get to the third toss. And so type into the direct message window for all to see how many different possible outcomes could we have from 3 tosses. Go ahead, type it in. Yep. And how is that related to the fact that there are just 2 outcomes for each toss? How do you get 8 out of that? Exactly, Andrew. It's 2 times 2 times 2, or 2 to the 3rd power. So if we had tossed the coin 10 times, then there'd be, in theory, 2 to the 10th different outcomes. It's actually important to know that. Notice, however, here, although we're using letters like we did in the combinatorics, there's not a fixed number of letters that we're rearranging. Type in for all to see what the top outcome here would be, assuming that we labeled all these the same way, where the upper branch is an H, the lower branch is a tails. Type in so everyone can see it. What would be the outcome if you took the upper branches all the way along? What would you have flipped? Exactly. HHH. And then, as you go down, you start mixing in some T's there. HHT, HTH. And notice each of these final outcomes represents sort of a history of your pathway there. Up, then down gets you to HTT. And so we could list out all 8 of these. And now, because we're flipping a fair coin, that is, we have 50% chance of going up, a half chance, and the probabilities are half that we go down, then every single one of these outcomes is equivalent. We aren't flipping a weighted coin. And so we could just count up all these possibilities, and we have 8 total outcomes that are all weighted equally, and 7 successful ones. And I just went ahead and told you 7, but you could see it yourself. How many of these have t's in them? Well, all of them except that top one. So 7 successes out of 8 outcomes gives you a probability of 7/8. Now this is overkill for this problem. So Ryan, I'd like you to jump back on the mic and describe again how you did this.
Yeah, what I did on this problem is I figured out the probability of it being heads every time. So I did 1/2 times 1/2 times 1/2, which is an 8. And then I took 1 minus an 8, and that gave me 7/8.
I hope that this represents it pretty well. So you smartly thought, instead of figuring out success, let me figure out failure. And why should you do that? Because there are a lot of different ways you can succeed. In fact, if I look on the previous one, I can succeed in all these different ways. Getting 1 tail, or getting 2 tails, or even getting 3 tails. And if I want to do this directly, I have to take all those into account. All these ones I'm boxing off. But it's much easier if instead I say, you know what would failure be? What would not succeeding be? And the probability of that H and then H and then H is just the sequential multiplication. In fact, this is very similar to the fundamental counting principle, that when I have successive choices that I'm making, and they're independent choices, just as my entree and my appetizer were, just as I multiply the choices I make, I could also multiply the probabilities for each of those choices. And I get the probability of that final choice. So then, the probability of at least 1 tail is 1 minus that, which is 7/8. Now, I noticed some of you picked A, which is very easy to do. And that's because maybe you did this, but you didn't do this last step. Of course the GMAT anticipates that you're going to do that you're not going to pick 7/8 because you forget to subtract the intermediate answer from 1. So, be very careful of that. When you use this 1 minus x trick, as we call it in the book, be sure to make sure that you subtract that from 1 at the end of the day. Notice also, because of that, because they like to put that trap in there, they didn't put in a 1/4 as a trap. This is an unpaired answer. So is this one. So if I had to guess without anything else, I would guess something that has a pair, something that has a buddy that would add to 1. So either 1/8 or 7/8. And 1/2 is its own buddy. Then I could use the intuition that Ryan and I spoke about to say, you know what, this is going to have to be bigger than 1/2. There's got to be a greater than 1/2 chance, greater than 50% chance that one of the tosses out of 3 will be tails, at least one. So that would lead me to D as well. So any questions on this one before we do a couple of last problems? Notice also how high this one is numbered. There was a question earlier, Razi, you asked about how many combinatorics problems should we expect to see. Between combinatorics and probability, I'd say 2. So maybe 1 of each. You might see 3. They're kind of related because when you're counting either the total number of outcomes or the number of successes, you might use combinatorics. In some problems you do. In this problem we didn't have to. We used this 1 minus x trick, which was much simpler. So, before we do these final problems, I want to make sure that you review these example problems. I don't want you to go off and look for all the weird examples out there. Make sure you review these sample problems we did. And then practice identifying those. And rehearse those strategies, as we say, until they become second nature. So, let's do 2 more problems and then we'll kick out of math. Here is your next problem. Go ahead. Okay, I'd like you to keep working on it, and I'm going to reveal pieces in silence on the screen and type things in, and you might change your answer as we go. I actually think with this one, it's useful to set up a little decision tree or probability tree to keep things straight. Now, what you have to be careful about is on this seniors group, what's the top and what's the bottom? This can be done with overlapping sets, perhaps. Yeah, let's come back to that. So, using this sort of probability tree diagram, what is success going to be to have a junior-senior sibling pair? So, my question is this being in a sibling pair, or is it something else? So, for instance, once we've gotten to this point, we have picked a junior. We've picked Sally. What then is success up top here? Picking a senior who's got a sibling in the junior class? And I'm going to go ahead and answer that question. It's not. Danielle, you jump on and describe what goes up top.
I think it's not just picking any senior who has a sibling, it's picking the senior who is, I'm sorry, I didn't hear what name you were using, but who is the sibling of the person that you've chosen from the junior class. So I think, well, obviously, I mean, that's only one, there's only one possibility. And I think it would be 1 over the senior class total, which is 800.
That's exactly right, and that's the trap here, is if you just put in a pair or not in a pair, then you're going to get the wrong answer here. Success in that second stage is not picking just any old senior who has a junior brother or sister. It's picking that particular person's sibling. And the chance of that success is 1 out of 800. And so what we get for the junior sibling pair is 60 out of 1,000 times 1 out of 800, which turns into 60 over 800,000, or 3 out of 40,000, which is answer choice A. Now, you can conceive of this by picking the senior first and then the junior. And if you do that, then the chance of picking the senior first would be 60 out of 800, picking a good senior. But then notice picking that senior's brother or sister is only 1 out of 1,000. So again, you get as the product 6 out of 800,000. And finally, another way to conceive of this is not quite as a double set matrix, but as a giant, much bigger than double set matrix, where we put the seniors across the top and the juniors along the side. And we've got tons and tons of boxes in here. Type in, so everyone can see it, if we've listed all 1,000 juniors down here and all 800 seniors across the top, how many different boxes would we have in this grid? So there are 1,000 juniors and 800 seniors. And each senior gets a row, or gets a column, and each junior gets a column. How many boxes would we have? Type it in so everyone can see. I have 800 columns and 1,000 rows. Exactly. I get 800,000 boxes. This is an enormous, this is much bigger than a double set. And then the question becomes, how many of these boxes represent junior-senior pairs? And only 60 of those represent sibling pairs. So you could directly pick 60 out of 800,000 that way. So there are 3 different ways to conceive of this, and you really only have to pick one. One is to say I'm picking the junior first, then the senior. And when you pick the senior, you have to make sure you pick that junior sibling, which is only 1 out of 800. Second way is basically the same thing, just flipping around. You pick the senior first, then the junior. Or the third way is this grid way, saying, well, I got 800,000 boxes. I got 800,000 junior-senior pairs. How many of those pairs are sibling pairs? Well, 60. So the answer I get is A. So this is definitely a hard problem. To answer your question, Andrew, yes, I see that Emily's typed it in. I don't think that the matrix would work here because you'd probably do in a pair both ways, and that would mislead you because you need that junior's pair. Let's do one more. This is a pretty tough one. This is a starred problem. This is close to the end of the 11th edition, which is numbered very similarly to the 12th edition. This is another rough problem. This is in your book. Here you go. I'm going to cover up. Actually, I'll go ahead and leave this diagram so you can see how to conceive of this problem. Go ahead. Okay, that's 2.5 minutes on this problem. This is a rough one. Very rough. Go ahead, put in an answer if you think you've got one. And if you're seeing this problem, you're psyched, because this is really, really rough. So don't get bogged down. Just take a stab if you're not sure. Okay, what I'd like you to do is to private text us what kind of problem you think this is. What kind of problem do you think this is fundamentally? Yeah, I'm noticing only a couple of responses. Amit, jump on the mic and talk about what you wrote.
Hi, can you hear me? I think that this can be taken as a fundamental counting principle problem, because if you see in the x-axis for each measure, I mean -4 to 0, you have 4 choices. I mean, since these are integers, x and y being integers, you can select x coordinate in one of the 4 ways, and the y coordinate for any triangle that falls on the left side of the x-axis in 6 ways. So that would be 4 into 6. Similarly, for the right side of the x-axis, which has a 5, which has a measure of 5, you can select each triangle varying with a measure of 1. So that would be 5 into 6. And similarly for 4 into 16, and then 5 into 16. But I guess you would subtract again 5 into 6 and 4 into 6 from the second measure, because that's already been accounted for.
Okay, some interesting thoughts here. Let me recap something you started with, which is the fundamental counting principle, which means that this is really a combinatorics problem. And how do we know that? Because it's asking us how many different somethings can there be, which is whenever you're asked for how many different ways can you do something, or how many different kinds of something or other exist, it's really a combinatorics problem. Now, then Amit was describing putting the triangles somehow inside this box. So we've got boundaries for where the triangles can live. I'd like you to type into everyone. There are points along here. We are told that the vertices, or the corners of the triangles, must be integers, which means that we have sort of a peg system. The corners of the triangles live in these pegs. Type in for everyone to see, how many pegs do I have along the bottom? Go ahead, type it in. Exactly. Notice that's 5 minus -4 plus 1 before you're done. So counting the integers between -4 and 5, including the 2 endpoints, gives us 10. So how many points do I have vertically along, say, the left-hand side? Go ahead and type that in. Exactly, 11, because I have 16 minus 6, and then I add 1 before I'm done, and I get 11. So how many total points do I have on the grid then? How many total points do I have? Type it in. I'm not going to try to draw every one of them. Yep. So I have 110 points in this grid, and I'm counting triangles that could be made in that grid according to certain constraints. The right angle has to be at P, so wherever I put P, That's where the right angle is. And then PR is parallel to the x-axis. That means that R has to be to the left or the right of P. And then Q must be up or down from P. At this point, having figured out that there are 110 points on this grid, I should be a little suspicious of answer choice A, because all the other answer choices are much bigger, and this feels like an intermediate stage to just have counted the placement of these points. Let me just go through the rest of this. So, skipping ahead to showing a possible triangle. Type in, for all to see, how many different places could I put P? How many different peg points could I put P in? Type it in. Now it's interesting, I'm getting some different answers here. Getting just one place, 11 places, 10 or 9, 90. Going back to here, could I put P at the upper left, upper right? Could I put it anywhere in here and form a triangle? Jean Laurent is right. We could put it anywhere along here. I just might have a triangle that's flipped around or something. P can go anywhere. So in fact, I have 110 possibilities for P. We've happened to have just drawn one P there. Now, once I've picked that P, again, this is a super tough problem. This is one of the last problems in the book. In fact, it's the second to last problem in the book. How many possible points do I have for R? Knowing that R must share the y-coordinate, it must be right or left. Once I've picked a P, where could R go? Type it in. Yep, Chris and Andrew are right. There are 9 possible R's. There aren't 10, even though there are 10 points between -4 and 5 inclusive, talking about integers, because we've got to eliminate P as a possibility. R can't be right on top of it. Finally, by similar argument, I have 10 possible points for Q, and putting it all together, the total number of possibilities for the triangle is the product of all these by the Chiles principle, the fundamental counting principle, which is answer choice C. Now, this is a very difficult problem. This is about as difficult as a combinatorics problem gets. And notice it's sort of a hybridized problem. It's got this whole disguise on top of it, which is coordinate plane geometry, which we haven't even gotten to yet. So this method actually takes into account every possible shape and size, because what you're doing is not saying, let me count up triangles that have just, a side of length 1 and a side of length 2, or that are oriented with P down in the bottom right. You're actually taking into account every possible way you could form a triangle. So I think it's easiest to pick P to begin with, and that's what really cracks this problem open, is not counting different types of triangles by their shape or by their orientation, but by the points that make them up and how many different choices you have for those points. So let's do this. Let's actually take a break at this point for 5 minutes. We're going to come back and do the essays and the rest, because I've hit you with the 1-2 punch of a couple different tough problems here. And if you have any, before we take a break, any further questions on this one? All right, grab a drink, come on back in 5. Okay, let's reconvene. The next section we're going to deal with is something I know you've all been staying up and dreaming about, which is the essays. And because this overlaps a little bit with the lab, lab number 6, I'm going to go pretty fast here. We've actually moved a bunch of this content into that lab, so be sure to do this lab this week, and I'll talk more about that at the end of this particular presentation. So the AWA is an abbreviation for Analytical Writing Assessment. This comes at the beginning of your GMAT, and it consists of 2 30-minute essays that you type into the computer. One is called Analysis of an Argument, the other one's called Analysis of an Issue. They can come in either order. These essays do not factor into the main GMAT score, the 200 through 800 score that everybody really cares about. So this is kind of an obstacle, a hoop that we all have to jump through. It is scored separately on a 6-point scale from 0 to 6, and actually the 11th and the 12th edition chapter 10 includes sample essays which are worth reading and potential topics which are not really worth reading. Sample essays, they give you 3 of each kind, a 6, a 4, and a 2 of the argument essay, and a 6, a 4, and a 2 of the issue essay. One thing that you'll notice if you look at those is not only are the 6s better written than the 4s, which are better written than the 2s, but they're longer. So one of the main things to do here is get your thoughts down on paper. Simply type in a lot of your thinking and you'll probably be fine on this. So let's look at how these essays affect you. As I said, the score is from 0 to 6, and you can actually get scored on the half point. So those are all the possible scores you could get. The percentiles are pretty skewed. As you see, almost half the people get 4.5 or above, which you say, oh my goodness, what if I don't get that? Well, here's what the school's reactions are, which is what you really care about. You get that 6.0, you're in that 95th percentile. Hey, you know what? The GMAT the schools say that's good enough. They aren't going to give you extra points for getting a 6.0. You get a 4.5, that's good enough. So the really important thing here is that the marginal difference to you, practically speaking, as an applicant to business school, is 0. That is, you get no added benefit out of busting your hump to get a 6.0 rather than a 5.5 or a 5.0 or even a 4.5. So why do these things matter? It's because of this other end of the spectrum. Really what it is that they want to make sure that if you score, say, a 1.0, but your application essays are beautiful, they're going to wonder who wrote them or who helped you write them. So the key thing is, do not stress about getting a 6.0. You want to do good enough on this, which means 4.5 or better, and you want to save your energy for the main event here. So let's talk about analysis of an argument. I'm not even going to show you an argument right now. I'm just going to say, hey, there's an argument with a bunch of flaws. And then the instructions are always the same. So take a look at these instructions, read them through, and give me a check when you're done. Okay, so there's a lot of verbiage here. The key things I find are these two items I'm highlighting. Use of evidence and line of reasoning. So the key thing to having a good argument is to dissect the argument along these two dimensions. So how well is the evidence used, and how good is the line of reasoning from that point forward? And I think the key to doing well on this kind of essay is to have found a bunch of the flaws. You don't have to find them all or discuss all the ones that you find, but you should do a pretty good scan. And I think using a couple of headers like this and then going through the argument line by line and asking yourself, how's evidence used here? How's the line of reasoning in this one? Challenging each line, challenging the pieces of each line will help you to brainstorm. Because what you really want to do is brainstorm out in the first few minutes and then outline. One way to help you brainstorm is what we call the CAST method. And as you are reading those lines and asking yourself, how's the use of evidence, what's the line of reasoning, you can ask yourself these questions. Look for a counterexample to what they say. What could disprove what's being asserted? Also ask yourself, what is the author assuming? An important thing that you have to do is you have to propose fixes to the argument, so you should say, how could you strengthen it? And finally, terms are really good. So focus in on vague terms that get used. And using the CAST method, you'll uncover a bunch of the problems. Now, how do you structure your argument here? You are not trying to write great literature. You want to say something as clearly as you can, and you're going to say it a few different ways over and over again. So first you're going to briefly restate the argument and give your high-level picture. Then you're going to go error by error. Your take will often include, say, here are the 3 problems I find. And then each body paragraph is going to say something like this. And finally, your conclusion is going to recap it. So guess what? You're going to say the same thing over and over. Just don't use the same words. So that helps sort of pad your argument out, your take, your essay, because you're going to say what you're going to say, then you're going to say it, then you're going to say it one more time. Just don't say it the same way. Issue is even more fun than the argument, because here you actually are going to take a side. You're not simply going to tear apart the argument. But you do need to have some balance to your point of view. You have to acknowledge the other side. So, yes, take a point of view on the issue that they give you. Support that point of view, and here you're going to make up examples from your life. You're going to draw in other things that you think of, but you want to think of both sides of the issue. And to help you here, we recommend a for-against type of approach. So first read this example, which is also in the 12th edition. I'll give you a few seconds here to read it. All right, show me an emoticon what you think about this here issue, this quotation. What do you think? Show me, do you give me a smiley face? Find it confusing? Thumbs down? Show me what you feel about it. Yeah, and Jean-Laurent's got a confused face. That's actually kind of my face too on this, because I don't know what a lot of these terms really mean. Power? What does power mean? Manifestations. What does impress mean? Right? So I'm not really sure whether I agree or disagree with this until I define the terms, and that's one of the main things you've got to do in that first paragraph. So first, brainstorm it. And as you brainstorm, you're going to be defining as you go. So take, I'm not going to have you actually brainstorm this quote, but as you jot down some fours, you might think, oh yeah, you know, Gandhi, Martin Luther King, my boss Jack, these people are restrained in their use of power, and that impresses people. And now you might have some against. You might think of Stalin, U.S. foreign policy. Now, be a little careful, because you don't want to be too controversial here. So after you brainstorm some fors and againsts, then simply pick a side. It does not matter which side you pick. And then the structure should look, in a sense, kind of like what we saw before. Restate the issue. Here, you've got to make sure you define terms. So what does power mean? What does impress mean? Then illustrate your reasons why you think restraint is what impresses people the most. Give those examples. And then re-summarize your conclusion. Again, you're going to say the same thing over and over again. Just don't say it the same way. So, we've got a course download for you, an essay handout. Even more important, do add number 6. You can submit your essays to GMAT Write for grading. You get a free round of essay grading. And GMAT Write is the same computer algorithm that grades the real GMAT. So you get one free grading from the very same algorithm that grades, that is the computer side of the grading of your essays. There are also human graders on the real GMAT, but this is a very important tool for you to use. And then finally, you should absolutely do at least one CAT with the essay section. Not so much that you get the essay graded, but rather that you need to build stamina, because the essay comes first. So you've got to get used to doing 4 hours of testing, not just 3, or close to 4, not just close to 3. It especially hits you on the verbal side when you've done the essays first, and then the math, and then the verbal. It's hard to concentrate. So you should make sure you do at least one practice test with the essays. So with that, let me hand over the mic to Emily, who's going to take us through the rest of today's work.
All right, thanks, Chris. And we are going to do modifiers today. We've actually seen these before, but we're going to break it down, everything you need to check and beware of. Let's begin with a problem. All right, let's call for answers on this one. And as those roll in, I'd like you all to type in just to Chris and I, or Chris and me, I should say, what modifiers do you find in this sentence? Go ahead and type in any modifier you found. You guys are typing that in. Remember that modifiers are descriptive phrases. We have seen them before. In fact, we've ignored them before as we found subject-verb pairs. We called them middlemen back then. See if there's anything here that is descriptive. I'll wait for a few more comments to roll in. All right, so those of you who have responded here seem to be all saying the same thing, this word which. What would be open to the public early next year? Now, Ganesh, you added something in your comment to this in the form of a question. Why don't you grab the mic and talk about that question that you posed? And how is that related to what I've highlighted up there?
Hello. Regarding the which could be open, you're trying to find out whether that will describe the park being open or the park's development being open to public. So that was the confusion that was in the answer choices.
Yeah, and he did what I think a lot of you spotted on this one. You guys were unanimous on answer choice B on this one. Not only is there a split between the phrasing of this comment here in commas, which could be open to the public next year versus perhaps open to the public next year, you also have a split regarding what noun actually precedes that comma. So is it development or is it park? And that's basically the issue on any modifier question. What is the descriptive phrase and what is it describing? So on the GMAT, you'll spot modifiers as descriptive phrases. They will typically be more than one word long. You know, of course, you could have a one-word modifier like an adverb or an adjective, but you often see phrases on this test, and sometimes they'll be set off by commas a good bit of the time. And there are other signal words that can clue you into the presence of a modifier. I'll show you some more in a moment, but what we have here is a relative pronoun, the which, that you guys spotted. Others are who and that. And so the problem is pretty clear. Once you realize that the thing that's going to be open to the public next year is the park, it's a problem that development is actually right there in front of the comma. Because the rule on noun modifiers is that the modifier must actually touch the noun. There are very few rare exceptions to that rule, but most of the time you really want those two to touch. And since we have a split between development and park, that's the issue that they're testing here. So that's actually what allows us to get rid of A and D. We want park in front of that comma. So what was the other issue that led you guys all to pick B? Go ahead and type that in and type it to everybody. You guys are awesome. That's exactly it. There's a split at the beginning and a split at the end that are really quite related. There's the form of this verb at the end, be, to be, or is to be, but that relates to what we see earlier in this sentence. So we have the commission proposed, and proposed is one of those bossy verbs that requires the subjunctive mood afterward. If what the commission is proposing is some type of action for someone else to take, we want subjunctive mood. And there are two signals for subjunctive mood, two things that you have to have. One is the word that. So simply that is enough to lead us to be as the answer. But the other thing that you need is the infinitive verb minus the word to. So to be, take the to out. We can get rid of C because it has the to still in there. And E is even worse with an is and a to in addition to the be that we want. So yeah, you guys are perfect on this one. B is correct. So that's something we'll talk about a little bit more next time when we do verbs or in an upcoming session here. But our first modifier question is simply this. Where's the noun that we want to modify, and is it in the appropriate place? When it's not in the right place, and when there's a split that moves the noun around, that's called a misplaced modifier. It's most likely that is the error that you're going to find. So make sure your modifier touches the noun. I'll hop back here. We got a question about D and E. We actually eliminated D for a couple of reasons, just to recap. It had development as the thing that would be open to the public next year. It should be the park. And the other problem with D is that there's no word that for the subjunctive mood. The B was okay at the end, but we needed the that at the beginning. E has the park in the right place, but no that at the beginning, and the wrong verbs for subjunctive mood at the end. Okay, first modifier question. Make sure the modifier touches the noun. So I want to show you a few examples of modifiers, the common forms that show up. An adjective, of course, works. Adjectives as part of a phrase would be a little bit more likely on this test, hungry for a bone, or you could say the hungry dog, same type of thing. Either way, this phrase is describing that dog. Here's another example, prepositions. We saw these when we were cutting out middlemen. One of the more common modifier forms on this test, so it pays to spot those modifiers. Usually these will follow the noun, and but sometimes they can precede it. On the sidewalk, comma, the dog walked. It can describe how the dog did something, and in that case, it wouldn't necessarily have to touch the dog, because it's describing the action. Prepositional phrases actually serve a couple purposes on this test. Noun modifiers and adverbial ones. Here are two participles, past and present, that a lot of people see and have a knee-jerk reaction on. The knee-jerk reaction is this: ed words and ing words are verbs, and that's not the case. It's much more likely, if you see either of these types of words, that they are playing a modifier role on this test. So really think about, are these descriptive phrases? And if so, go looking to see that they describe the right thing. You might phrase these as questions. Exhausted after a run? Well, who was or what was? And that answer has to be right after the comma. The dog was. When an ing word follows a noun like this, it describes the dog or describes that noun. A couple others. Relative pronouns. We saw that with which in the park question, but we have that and who. Who is only used to describe people or named animals. Inanimate objects and other animals would go with that or which. And finally, you can actually have a noun phrase modify a noun. That's called an appositive, and it basically is like an equal sign. Oh, excellent question, Danielle. What's the difference between that and which? I'll show you an example here on the next page. When you have a noun next to another noun, just to close out this example, the comma here sort of works like an equal sign. What is an example of pure breeding? This dog is. They are equivalent with each other. Now Danielle is asking, what's the difference between that and which? And the difference is whether you need the modifier for meaning or whether you don't. Okay, and here's an example. The dog that won Best in Show is a beagle. Now, in this case, that won Best in Show describes the dog, just as a relative pronoun will always signal, modifying the noun right before it. But watch what happens when we take this out of the sentence. I'm going to block it out. And I'm left with the dog is a beagle. And that may be true, right? But I have lost a lot of meaning there. My original intent was to talk about a particular dog, not just any old random dog. So that one Best in Show is an essential modifier. So let me label that. And in contrast, when you use which, it's for something that isn't necessary. So the dog, comma, which is brown, is a pug. That phrase, which is brown, is kind of nice to know, but if I take it out of the sentence, it's no big deal. I'm still talking about just any old dog. I just don't know what color it is. So this is what's called an inessential modifier. Give me a smiley face if that makes sense. And I've got to give credit for this example. I found this in a book called Woe Is I. It's a pretty readable grammar book if you're looking for something to read. And along with it, there's a rhyme that I find very helpful. The rhyme is this: commas which cut out the fat go with which, never with that. And you'll notice that that's true here, right? This is kind of a fatty modifier. It's inessential. It's the fat in the sentence. And it's set off by commas because it's not necessary. Commas which cut out the fat go with which, but never with that. And on the GMAT, they usually don't test the comma placement so much, but that's a good way for you to remember that which goes with fatty modifiers or inessential ones, and that is integral to the sentence. No commas to set it apart. Yep. And I think Chris is typing that in for you guys to remember. Get that in writing there. Here's our next example. Okay, Chris Lake, would you grab the mic and talk about what you saw in this sentence that you'd like to fix? You picked an answer that wasn't A, so there must have been something about A that disappointed you.
Yeah, I didn't like the beginning of the phrase using a Doppler ultrasound device modifying the fetal heartbeat. So I moved on from there, looking at the rest of the choices. If you could go back, I can review what I didn't like about it.
Yeah, sorry about that. I flipped the slide on you just to illustrate what you're talking about. That using a Doppler ultrasound device is set off by commas. It's also not a complete clause. So it begs the question, right? You could form it as who was using the Doppler ultrasound device? And the logical answer to that question ought to follow the comma. And so Chris was saying, well, it just doesn't make sense here. The fetal heartbeats were using the ultrasound device. Really? So Chris, what did you do to fix that error? We heard you pick up, but then I think you clicked right back off. So go ahead and pick that up again, please. All right, that's really bizarre mic issue. It's picking up and then fading away. Let's throw that open to everyone. Who would use a Doppler ultrasound device? And in what choice do we find that person? Just type that in. Person or thing. All right, you guys have nailed it. And you know what? Are you expected to know that a physician would use it, not a technician or a nurse or somebody else? No. What matters is that you find a choice that has somebody who could reasonably use a Doppler ultrasound device in that place. And choice E, which most of you picked, has that physician where the physician ought to be, has that person there. So you can get rid of A and B both in this sentence because they both have that phrase, using a Doppler ultrasound device, without a logical noun to be modified by it. Okay? Can anybody tell me, though, why are C and D wrong? I mean, they have the physician in there. Nobody picked these because they changed the sentence, I think, more than is necessary to fix the original error. But what errors do they introduce that make them clearly wrong? Raise your hand if you think you can take that. What are the complaints with C and D? Angela, you want to take a stab at that? What's wrong with C and D? It looks like Angela may have stepped away. Andrew, you're typing. I'll throw that question to you.
I just want to say first that I got this wrong, but I was going to say about C and D is that if you switch the two phrases around, they don't necessarily make sense. For instance, I guess for C, a physician can use a Doppler ultrasound device detecting fetal heartbeats. Well, I guess that one does make sense, but D didn't make sense to me. But because of the by, I guess, for that one.
Yeah, you mentioned two different things because there are two different things that disqualify C and D. So let's talk about C first. The order is different, right? Detecting is part of the modifier, and the main verb is can use. That's the exact opposite of what we started with, using as the modifier and can detect as the main verb. And that affects the meaning, right? Because one of those things implies the first activity and the other implies the result. How does the physician detect? By using a Doppler ultrasound device. How does the physician use a Doppler ultrasound? By detecting fetal heartbeats. C implies a strange meaning by swapping those two. Yeah, and Rosie's pointing out, well, D is a little bit wordy, and Andrew complained about the by in D. What is by a physician? What should that modify? Everybody type it in. This is a prepositional phrase. What is by a physician in D? question is for everyone, especially Andrew, since you brought this up. You didn't like the by here. What's confusing about this?
Is it that what is detecting the fetal heartbeats? Is it the Doppler ultrasound or the physician?
And I think you are sort of overlapping with what Ryan is saying. Fetal heartbeats aren't using the Doppler ultrasound device, because as Razi pointed out, this is wordy because it's passive voice, right? Fetal heartbeats can be detected. That's a passive verb. So who's doing the actual action? It should be the physician, right? Somebody who could actually do something actively. And Ryan's saying, okay, then the by phrase actually sort of modifies that verb. It really needs to go over here. Detected by a physician using a Doppler ultrasound device would be okay for D. But the placement here at the end is kind of weird. It makes you think, well, maybe it's the device that's by a physician. So there's confusion with the placement. And you'll see that a lot of the time with modifiers. There's this overlap with meaning issues. So we check to make sure that our modifiers touch the appropriate noun, but the second question to check on a sentence is the actual noun to modify in the sentence? When it's not, that's called a dangling modifier. Okay, you want that noun to actually be present there. And one clue is that, that this is an issue is you see a noun in some of the choices and it's not there in others. All right, pause here if people have questions. Here's our next problem. All right, guys, I see a variety of answers. I see actually 3 answers represented here. Let's talk about the first split that's up here. Even though it's not necessarily our issue for today, I'm sure you guys spotted this. There's saw and there is seen. What tells us which of those two to pick? Type that in just to Chris and me. All right, you guys are fantastic. Visitors have often looked, and those same visitors have seen. We want parallelism. The visitors did 2 things. There's a shared subject. The verbs ought to be parallel. And since have saw is not the right form, it's have seen, the past participle, we want D or E. So that's a parallelism thing, arguably a verb tense thing. But undoubtedly from there, you'd still have to make this choice, with or whose. So, let's see, Roshan, how do you decide between with or whose? Did anybody else hear Roshan? Alrighty, I'm having no mic luck. So Roshan, I'm actually going to change the chat so you can type that into the class. Why with or why whose? Well, it's a really interesting way of looking at it. Whose could refer to the visitors. Yeah, there's a couple things about whose that are important to us. For one thing, whose should only refer to people or named animals, not the generic monkeys that we have in this question. If we want to refer to monkeys, we would say that, right? The other thing we need to know about whose is that it needs to be next to the modifier, the modified noun. Which, whose, that, they're really picky about being next to the noun that they're trying to modify. And as Danielle's pointing out to us, look at what we've got in front of the comma in all of these cases. We've got branches. So that's even more nonsensical. Branches don't have arms and legs. Okay? And we're not free to move that phrase around. If we did want to say it was the visitors whose arms and legs have hung, we'd even have to put it closer to the visitors. So even if it were the visitors we intended, this phrase would be in the wrong place. Yeah, it's got to be with. And so D is the right answer here. That's what we're dealing with here. We've got the wrong noun modified. And what's new about this compared to the misplaced modifiers that I've shown you before is not only do we have a placement error, we have a fix that offers us a different type of modifier. The whose phrase is a relative clause. That's a noun modifier. It has to be right next to the noun we intend. But a with phrase is a prepositional phrase. And that can be a noun modifier, but it can also be an adverbial modifier. And what we mean by that is it describes the action. It tells us how the monkeys were doing something. Sort of describes the monkeys in doing so, but more accurately it describes what the monkeys were doing or how they were doing it. Yeah, and so Ganesh, you're right. There's sort of a verb split also around has hung. You could say this is probably a red herring. You know, they might be trying to appeal to you with this have hung as a match to have looked and have seen. I think it's not wrong, but it's misleading. It might lead you into picking this for verb reasons when the modifier is incorrect. What we see with hanging is a modifier, actually. This isn't a verb, it's describing the arms and legs. Arms and legs hanging. And so that's new. Adverbial modifiers are different from noun modifiers. They're more flexible. They don't have to touch the modified verb. They can be at the end of the sentence, completely away from it. So they can be plain old adverbs, which often end in an ly, or they can be prepositional phrases, as we've seen on that last problem, and as we see in this example. The reason they don't have to touch is there are usually fewer verbs in a sentence. So the meaning is still clear, even though they're apart. If you had several actions in a sentence and wanted to modify each one of them, then you'd probably want to tighten it up. For example, Jim walked slowly, talked on his cell phone loudly, and tripped clumsily on the sidewalk. In that case, I've got three verbs. I'm just modifying each one of them, and I'm making the modifier touch the modified verb. I'm going to let Chris answer some of your questions about verbs, just so we stay on modifiers and get through the questions that we need to address here. One big point that I want to make about adverbial modifiers is that the placement can greatly affect the meaning. So really be on the lookout on any question where you see the GMAT writers moving a phrase that has to do with time or place around. I want to give you 4 examples down here at the bottom. Notice that these sentences are basically all the same words, and all I'm doing is moving the only further into the sentence. You know, either at the beginning, 1 word in, 2 words in, 3 words in. Read through these real quick, and give me a smiley face if you see what the big meaning differences are. And I'm hoping that you guys are picking up on this. Just by moving this adverb 1 word at a time, I've changed the meaning, right? If I say only Luis ate birthday cake, it means nobody else did. If Luis only ate the birthday cake, it means Luis didn't eat anything else. If Luis ate only the birthday cake, means he didn't eat any other food. Or actually, Luis only ate the birthday cake means he didn't do any other activities. And if we say Luis ate the only birthday cake, it means there was only 1 cake, and he ate that one. So 4 different meanings from sentences that have all the same words. Placement matters a lot. Whoops. Oh my goodness. I have been talking about another slide that's up here. No wonder I wasn't getting responses from you guys. I'm very sorry for this. And I think Chris would have caught it, but he cut out there for a moment as well. Okay, so let me back up here. We covered why we want seen. And we talked about why whose is modifying the wrong thing. It's modifying branches, which isn't appropriate, whereas the with can modify the action, the sleeping on the branches. So you guys with me on this slide? Give me a smiley face if you are. And then I'll show you what I was just talking about there. All right, thank you very much. And sorry I didn't catch that earlier. Yeah, so adverbial modifiers can be placed away from the verb that they are modifying. In this example about Jim, or actually both of these, the verb is modified by these phrases or words, but they don't have to touch, because there's no chance of thinking that it's Jim that's slowly or work that's slowly. It has to be his action. Okay, so these are the examples that I was talking about, and take a spin through these, read them to yourselves, and smiley face at me now if you can see what I was talking about difference in meaning. Okay, so the big takeaway there is, you know, if they give you a choice where a phrase about time or place simply appears in different locations in the underlined section, a little bell should go off in your head, and you should think, maybe there's a meaning issue at work. So eliminate as many choices as you can based on grammatical issues, and then read what's left with an eye on what the actual implied meaning is. All right, let's take this as our next example. Okay, last call for answers on this one. I see some last minute switching, and that's all right. For the most part, you guys are switching to the right answer, those of you who are switching. A consensus has formed around B. So, Ryan, would you grab the mic and tell us why you picked B? What splits led you there?
For me, I really focused on the word orbit. It really seemed to me that it needed to be known to orbit to make everything match up correctly. I know that there was a split between doubling and which doubles, and I thought the doubling was a better choice as well.
Yeah, I'm curious how many other people use this known to orbit versus known as orbiting, known that orbit split first. Smiley face if you did just as Ryan did and relied on that split in blue there. That's interesting. Ryan seemed to rely on it quite a bit, and it worked for you, and John Laurent, you did as well. This is an idiom split, so good technique is to leave that to the end, so I think it was really good that Ryan also took note of this other split at the beginning, sort of as a verification that you'd also picked the right choice for other reasons. Now, why did you like the doubling instead of the which, Ryan? And maybe another way to ask that is, what does the which refer to? What doubles to 12 the number of satellites? Known.
What do you want me to answer? I was unclear on that.
What I was asking is, you said you didn't like the which. You liked doubling instead. What is it about which that you dislike?
I thought that which made it more of an optional statement, and doubling makes it more definitive.
And it is true that we have said that like which is set off by commas because it's kind of optional. And I think this phrase, even with the ing, is set off by commas, so it's technically optional. In fact, we could cover up the last part of this sentence, and we'd have something that's grammatically correct. The cameras detected 6 moons circling Uranus, 6 new ones. And that would be fine. So either way, we've got something optional. That you use the word definitive. What is more definitive about the doubling? And let me throw this out to everybody. When we use which, is it clear what doubles to 12 the number of satellites known in orbit? What actually lets us know that there are 12 satellites now? What doubles to 12 the number of satellites we know about? Type that in just to Chris and me. Yes, I'm getting a variety of answers here. I'm getting one school of thought, which is saying that it's the new moons that we know about, the 6 small previously unseen moons. But my follow-up to that is, well, weren't they always there? What is it that allowed us to know about them now? It's really the knowing about them, right? So some of you are following up with that and saying, well, it's the fact that the cameras detected it. In fact, that's the way Danielle phrased it. The fact that the cameras detected those moons is what now leads us to know that they're there. Brooks put it another way. He said, and Jean Laurent as well, they said it's the detection that allowed us to know. Okay, the detection or the fact that the cameras detected them. Either way, that would be accurate. But notice that what that is a noun. Okay, so if we had the detection comma, which doubled to 12, this which would be used correctly, because which would be modifying a noun. The problem with this sentence is that not only is which modifying the wrong noun, the planet itself, it's sort of trying to modify a verb, right? The detected. It's not here in noun form, it's here in verb form. And a which phrase cannot modify a verb. Give me a smiley face if that makes sense to you. Which only goes with nouns. Yeah, and we do misuse which all the time. I completed my homework, which made me happy. Right? It's the completion of my homework that has caused my happiness. I'm misusing which in that sentence. Yeah, my grandpa fell off his truck. So what that means for us is we want to avoid any choice that has which in it. And we do so here, and you guys are right, those of you who picked B. We have doubling, which is a different type of modifier. I'll show you on the next slide what kind it is, and it has the right idiom. It's not known as orbiting, it's known to orbit. So let's talk about which versus ing, because we actually saw examples of every type of way to see this in this sentence. Which can only modify nouns and can only modify the noun right in front of them. They're very picky like this. An ing word can modify several different ways. When it follows a noun without a comma, it modifies the noun right before. So 6 moons circling, which moons were they? The ones that were circling. Okay. When there's a comma followed by an ing, that's a lot freer. It can modify either like the verb of the whole preceding clause, or it can be considered to modify the entire thing. Right? The cameras detected the moons. And what you'll often see is an ing phrase indicating the result of that preceding clause. So here's another example. The piñata burst open is my main clause. What's the effect? Inciting a candy-grabbing frenzy. Okay, so you can literally think of this as clause and effect. Okay. Any questions on this? So if you see a which versus ing split, I would say look closely at the which choices and see if they're doing the right thing. Or if they are supposed to be modifying a noun, make sure they're modifying the right one. Alrighty. So here's a quick modifier summary. I'll pause here just to let you guys catch up on your notes. Give me a green check when you are finished with this slide. Yes, and just to refresh your memory, dangling modifiers occur when the noun is missing. Intended noun is missing. You guys will probably remember our physician example. And a misplaced modifier is when you have multiple nouns modifier in some cases next to the wrong one. So there are different split clues that you can look for. And in fact, I should have mentioned this. Split hunting is a little bit different on modifier questions. When we saw subject-verb agreement splits, or when we saw pronoun splits, very often we saw situations like this, where we had our choice A, B, C, D, and E, and like a line of text attached to each one of them. And the splits on some of the other grammar issues tend to line up with one another. So like you might see a verb tense split at the beginning and a pronoun split at the end or something like that. On modifier splits, what you're likely to see are splits that have to do with placement. So, for example, you might see one long phrase that appears at the beginning in some choices, in the middle in another, and at the end of other choices. Yeah, so you don't want to scan so much vertically. What you are looking for instead of differences that line up is similarities that don't line up. So placement of the phrase, as we saw with that only example earlier, can make a big difference to meaning. The other clue that you might have a modifier issue is simply a lot of underlined text. If they are moving big phrases around, they're going to underline a lot of the sentence. So you'll tend to have longer choices. Okay. I'll pause here again. Make sure to give me a green check when you're ready to move on. Sure thing. So an ing without a comma signals a noun modifier. And like all noun modifiers, they need to touch the noun that is modified. So I'll give you a couple of examples. The girl singing is loud. Okay, which girl am I talking about? The girl who is singing would be an alternate way of phrasing that. See how singing describes the girl. Not necessarily her action, because the action's actually this, is. That's our simple verb there. When you have an ing with a comma, it's an adverbial modifier. The girl was loud singing at all hours of the day. And in that case, this phrase is singing at all hours of the day basically describes how she was loud. It modifies that entire first clause. I'll sort of give you an example of why we say she was loud. So Ryan, let me know if that helps out. Just give me a smiley face if so. Yeah, so Ganesh is asking a great question privately. He said, is the ing with a comma going to modify a noun or a phrase? It's going to modify the phrase if it's at the end. It is complicated. You can have an ing phrase at the beginning that's set off by commas. For example, singing at all hours of the day. Jane woke her roommates up. And in this case, I think you could say, even though it's set off by a comma, this is sort of modifying the noun, right? It tells you who, well, you ask who's singing at all hours of the day. Jane was. Yeah, so it could be both. But what I think you ought to take away is that when ing has no comma, it must be a noun modifier. Ing with a comma could be either. And it's that freedom that actually makes it somewhat easier to use correctly. But double check. All right, I think let's move on. If you guys want to come back to this, we will absolutely do so. But I want to squeeze in one last thing tonight. As a quick mid-course review, I want to show you a new problem that has to do with an old topic. And we're deliberately going back a couple weeks to material you saw in number properties. So I'll give you 2 minutes on this question. Pull in your answers when you've got one. This is awesome. I've got answers from everybody in just under 2 minutes. And look at this. Complete unanimity on what happens to be the correct answer. So I showed this one to you not only just to touch on a subject that we've seen before, the idea of roots, factoring, exponent rules, and so forth, but also to make a point about test-taking skill, okay? Because there's knowledge of the math, and then there's knowledge of the GMAT and how they do things. So I want you to look at this problem from a different perspective now. Look at it not from the point of view of a test taker, which has you look at it like, what do I do and why? That's this. You factor so that you can deal with what's under the radical sign. We factored the 80 into 16 by 5 with an eye on getting perfect squares that we could then pull out this 4 from the 16. Likewise, 5 and 25. The 5 has to stay under that radical sign, but the 25, the square root can be pulled out, and that's where we get the 5. And then it's a matter of simply summing those. 4 of them and 5 of them give you 9 of those radical 5s. So that's what you're supposed to do. But from the test maker's perspective, one of the hardest things to write about a question is the wrong answers, right? Because the right answers sort of write themselves. There is only one right answer, but they have to give you answer choices that aren't giveaways and might trap certain people. So can anybody look at these choices and think, you know, where did these come from? They're not random. Where did they get them? I'll pause here while you guys think about that. In fact, I'll give you 30 seconds. Start typing in anything you can think of. A few more rolling in. I'll pause while you guys finish typing. This is great. You guys could write wrong answers and do a great job at it. Think about all the things that people would do incorrectly. Good setup, but miscalculations along the way would lead you to B and C, as you guys pointed out. The 41 is 16 plus 25. Incorrectly multiplying instead of adding the 4 plus 5. Incorrectly putting 80 and 125 under one big radical sign. That's bad setup and bad procedure. But it's a number that you could get if you took the wrong first step. And you guys pointed out a couple of reasons why you might end up with 100. Roshan's saying, okay, well, it's an answer you might get by approximating. And you could also multiply under the square root and actually compute 100. So the point is that they know what people do incorrectly. And one of your jobs on this test is not only to know how to do it right, but also what are the things that are likely to trap you if you temporarily sort of mess up and forget the right thing to do. These are the pitfalls to be aware of. Okay? And this is one way to review a problem even though you've gotten it right and even though you've seen it before. So we strongly recommend that you revisit questions periodically after a few weeks perhaps. Even if you still remember what the answer is, redo it as if you haven't seen it before. See if you can walk through the steps again. And as you do, check the following. Do you understand what the question is about? Can you name what the topics are? Can you name which of the strategy guides and which chapter you would find that content in? Does the explanation make sense to you, the one in the book? Look back at your process. Evaluate your scrap paper at this stage. Could you have simply done this in a more robust way? Something faster, something more likely to lead to the right answer, something a little less error prone. That's great to deconstruct after the fact without the timer running. The test sophistication angle of this. I'll tell you right now, the big difference between earning a 650 and earning a 750 is not knowledge of content. It is error avoidance. How is the GMAT trying to trick you? If you know how they're trying to trick you, you're less likely to fall for the tricks. And finally, what do the answer choices reveal? You'd be shocked how often the answer choices reveal about the correct answer, the way the answers are paired. We saw that today. Answers that add up to 1 on a probability problem or up to 100 on a percent problem. Paired answers might indicate which ones are right and which aren't. Max and min, likely answers. Did you fall into choices that you shouldn't have picked simply from a common sense standpoint? Keep a list of any problems that took you too long to do, you either got wrong or they just felt funny to you, even if you got the right answer. Revisit those or put them on flashcards. And you can refer back to this handout. It's from session 2. You can download it off the website if you want a little bit more in terms of tips on how to review. Okay. So I think we will end there. We've kept you late several weeks. So look at this as us giving you a few minutes back. We'll stick around to answer some questions, but if you don't have any questions, you're free to go, and we will see you next time. Razi, I see you've got a question, so why don't you hop on?
Starts to reviewing, and at this point of course, if you find that some of the problems you're doing from the past are taking, way substantially more than, like, say, 2 minutes, 3 minutes, some even 4 minutes, is there a point to, like, kind of say, hey, you know what, I'm just give up, I'm trying to solve it, and just figure out why it is that, it's taking so long, and just really go back and review the content as opposed to spending like 5-10 minutes trying to solve a problem?
My answer to that is going to be a two-part thing. First, I would look at whether the questions that you're taking too long on are from the same content area over and over again. If you are always spending 4 minutes on an overlapping sets problem, it's because you haven't really made the double set matrix automatic for yourself. In that case, I think you should go back to the content and really review and do more problems in that area. On the other hand, if you are spending 4 minutes on sort of random problems throughout the book and in a variety of topics, it's likely that it's just the more difficult problems in every batch, or certain problems that hit you the wrong way. In that case, I think you should revisit, not from a content perspective, but from a test sophistication standpoint. It's only to train yourself for what to do on test day when something is taking too long. You want certain guessing strategies to be a little bit automatic. And a big part of that is simply being willing to give up on a problem and guess when you need to. So, Razi, let me know if that answers it for you. All right, cool. I'm going to change the polling to green check and red X. Give us a green check if you're all set and you're just hanging out to see what other people are asking. Give us a red X if you've got a question that you want us to address. Andrew's asking a very common question. How much higher, should you expect to score on the actual thing from your very first assessment test? It really does vary wildly. What I use as the best determinant, I think Chris agrees with this because I think he's the one that sort of recommended this to me way back when, is the average of at least 3 tests. Usually your latest 3 or the 3 that are most representative. Don't throw out the lowest scores you got on practice tests just because they're lowest, but it's fine to ignore some from tests that you got interrupted on or something like that. Something unusual occurred during them. But at least 3 tests, take the average, and that seems to be a pretty good predictor. Yeah, usually the first test is least predictive because usually people do improve. But I like to see, let's say you're aiming for 700, I like to see at least 3 tests that are in that ballpark to be confident in your chances of hitting that.
Oh, yeah, what I was going to say about the next test you're going to take, I thought that maybe the question you were going to ask, Andrew, was about what the next, would your score go up? What's the average increase on the next test because you're due to take one for next week? It can be very common that you plateau, that you could even go down from your first test, and that's, I know, frustrating. We see it happen quite a bit, and there are several reasons why that can happen. One reason it can happen at this point is that you're now engaging with questions that you would have skipped over earlier. You're now saying, yeah, you know what, I've learned some word translation stuff, so I'm going to dive into that tough combinatorics problem. But you haven't mastered the subject yet necessarily, so you can actually be less efficient. Time can come back and hurt you more on say, your second CAT than on your first. Also, you've sort of messed up your first way of doing things intuitively, but you haven't yet totally, it's kind of like fixing your golf swing or your tennis swing. While you're learning the new one, your old one's messed up. So please don't overinterpret this next score either, even though you feel like you're pretty far along. So use it to be pretty. Don't worry as much about the overall score, although of course you're going to try to do your best, but rather use it as a way to diagnose specific either content or process or test sophistication issues, as we've got listed there. Okay, thanks everybody. We're going to stop the tape now and hang out for a couple more minutes, but otherwise we'll close up the room.